Okay, so coming back now, we are practicing the law of sines, and then we're going to also talk about the law of cosines since we haven't really talked about that. So in this problem here, it says you can use any of these strategies to find the area of this triangle. Okay, again, area is base times height. And so if you did draw an auxiliary line here or wherever you wanted, that could definitely help you. But I prefer to use the law of sines or cosines just because it's there. Just so you know, this over here, and if you want to like jot it down, I don't know where I put it now. I copied it. Here it is. This is your law of cosines, okay? Versus your law of sines. I will write down your law of sines right above it. Actually, you tell me, what is the law of sines? In the chat, can you put that? Oh, nice. Very good. Okay, yeah. So the law of sines is sine A over little a, sine B over little b, and sine C over little c. You can also make them all do a handstand so that the little a's are on top. It's just whatever you prefer. I like to see it like this, so this is just my preference. Or you can use the law of cosines. This is not an either or. This is when it's, yeah, handstand. Like the top is on the bottom and the bottom's on the top. It's not a flip. Like some people call this a flip. It's not a flip because the top is the bottom and the bottom is the top now. All right. So this is not an either or. Use law of sines or law of cosines. It's based on what they gave you to find what you are missing. Does that make sense? Like, so I think about this as being ingredients that they set in front of you, and you have to make something with it. Like you have to make a dish. Now, certain things you're going to use certain tools to make the dish, but you can't like you'll see which one you'll be able to use based on what they give you. Does that make sense? You'll be able to understand which tool you should be using based on what they give you. Okay. For this one, I already know that my law of sines is going to be used. And I actually prefer to use the law of sines over the law of cosines because look at the actual formulas, right? Which one would you rather use? Would you rather use this one? Simple. This one complicated, and there's three of them that you have to choose from. Yikes. You'll understand as soon as you start seeing them. Okay. So it says find the area of this triangle. So the first thing that I do is if I'm trying to find the area of this triangle, right? I need to find the altitude. I need to find like this guy here, right? So I'm going to have to like do a couple of things. Okay. So with that being said, what would be your first task in this problem here? What would be your first task? What's the first thing that you would try to find? Yeah, find angle C, right? That's the first thing that I do too. Let's see, 90, 104. So I get 76. Is that right? Is that what you guys got? Please say it if I'm wrong, because I'm not like at all like I'm okay with saying, Miss Johnson, you're wrong. Did you guys get 76? Someone help me. 30, 90. Yay. Okay, 76. Sorry, I was just waiting on confirmation. Okay. So because I have all three angles, and now I need to find these sides, I'm going to use my law of sines and cosines. So I'm going to write sine of 76 over C, and then sine of 68 over B, sine of 36 over A. Now, when you look at this, what's the problem? Oh, 180 minus these two angles gives me 76. So remember that the sum of the angles of a triangle equal to 180. Okay. So what's the problem here? Anybody see my problem? Very good. Miss Johnson, you forgot that A is 12, so rewrite that. So who's going to be my helper? Who's going to help me the most here? Yeah, this is going to be my most helpful here. Ms. Johnson, why is this going to be the most helpful? Because I know it and I know it, right? So I'm going to solve each of these, and then that's going to get me B and C, and then I'm going to have to find my altitude. Okay. So with that being said, I'm gonna handstand these because I want my variable on top. So I'm gonna go B over sine 68 equals 12 over sine 36. This is the math that I expect to see on your test, so don't neglect this. So therefore, B is equal to sine 68 times 12. I'll throw the 12 in front, divided by sine 36. Please don't do the thing where, hold on, let me let that catch up to you. Some people think that I can like cancel out these 68 and the 36, right? With twos or whatever. You can't. Because this is the sign of a number. This number is a completely different number than sine of that. So I'm gonna plug this in. So 12 sine 68. I already know that I'm in degree mode, but I will check anyway. So I get that. And then I check, I am in degree mode. So therefore, B is about 18.299. 929. B is about 18.929. So I'm going to write that here, right? And then I'm going to do the same thing with C over here. C over sine 76. Any questions for me? Actually, I want you to do this. I want you to find this. And then when you're done, throw your answer in the chat. Go ahead and solve this equation for C and then label it all out. Then it's asking you to find the area of the triangle. To find the area of the triangle. Okay, so find C. I'm going to pause it really quick and then give you some time. Find C. So go ahead and find C and then find the area of the triangle. Okay, if you found C, so you should have found C is equal to 12 sine 76 over sine 36. And then you would have plugged that into here, which is the same exact equation as this, except for the 68. I'm just going to rewrite this. So 12 sine 76 divided by sine 36, it's already in degrees. So I got 19.809. C is about 19.809. Okay, so you're kind of done here, except for you just need the height. And so the easiest height for me to draw is this one. You could draw this one. It doesn't matter which one you draw. Oh yeah, that's fine. Either one of those is fine. So I'm going to draw in this this auxiliary line as my height, and then I'll use C as my base. Do you know a way that you can find this height? Is there a formula that you know to find this height right here? Yeah, either one of those works, hon. So do you know formula to find this H right here? Yes, very good. We can use sine of B. You can also use sine of A. It doesn't matter which one you use. So once you find that height, then you can take your height and multiply it by your base divided by 2, and that's your formula. Okay, so I'm going to walk through that really quick. Someone said sine of B, so I'll go with that. Sine of 68 degrees equals to H over, is that 12? 12. So 12 sine 68 is your height. So that's about what? 12 sine 68. So it's about 11.126. 11.126 is your height. So now you could just take this and find your area, right? So area equals, and then so this is what I'm going to put in black. So area equals half times base times height. Oops. Right? So in this case, it's half times C times H. And so that's equal to half times 19.809 times what we just found. And so I'm just going to plug that into here. Oh, that's 11.126. So I might as well just keep that. So there's my C. So times this by 19.809. And then this whole thing divided by 2. So there's my answer, 110. It's 110.2. So this is units squared. Imagine tiny little Post-its covering this whole thing. That's my answer, 110.2. Any questions on this? Definitely a question on the test like this. Find the area of this. For sure, make sure you're comfortable with that. Ms. Johnson, how did you know that you're going to use sine? I'm going to just tell you my default is to use sine. And if I can't use sine, I'll show you an example that you can't use it. Then I'll jump over to law of cosines. Any questions on finding area? Any questions on finding area? Any questions on finding area? No questions. We're good. Okay. So then it says find the area of this triangle, and they're trying to get you you tell me what the final answer is. Find the area of this triangle. What would the final answer be? You guys tell me what's the final answer of this? No, squared. Don't forget squared. Units just means toothpicks. Unit squared means Post-its. Whenever you're looking for area, it's got to be squared. Okay, so then they want you to find the area of this triangle, and they want you to be generic. So here, when you looked at this, and again, this is so that you can use the, like, kind of find this formula for it. So let's look at this. This is the formula that we used, right? Does everybody see my formula right here? Okay. So I'm going to use this formula to build a generic formula, one that you were talking about. Someone in here asked, hey, can I use this formula that my brother in college uses? Absolutely. But here's where the formula comes from. Do you all agree with me that the formula to find the area is half times base times height? Is everybody comfortable with that? Everybody comfortable with that? So over here, you guys told me how to find this height, right? You guys told me how to find this height. Generically, what is h equal to? If you had to write me an equation that told me what h is, what would that be? How would you write an equation to find height? Generically, how would you find the equation to find height? Now, if you don't remember, come right back up here. How did you find the h here? What formula did you use? Very good. You used this formula, which was the sine of 60. Oh, sine of that equals to what over what? Can you write a similar equation to this down here? Can you write a similar equation of this down here? So someone said it's going to be sine, Miss Johnson. So sine of what equals to what over what? Sine of what equals to what over what? Yeah, someone said sine 68. Very good. But in this case, 68 is who? B. Very good. Equals to. Now, the people who got it wrong earlier, your SOHCAHTOA. You people who got it wrong earlier with your SOHCAHTOA, sine of B equals to what? So if you get things wrong during practice, that's awesome. Let's get it right during the test. Okay, so sine of B equals to what? Very good. I got H over A. I got several people on that. So if I solve this for H, just like we did earlier, we would just multiply by A, multiply by A. So H is equal to A sine B, right? So I can take this guy instead of this guy. right? I can rewrite these two for each other. So then I'm going to write A sine B. Is everybody comfortable with my A sine B? In this case, if this is my height, who is my base? In this case, if this is my height, who is my base? Very good. Yeah, it's C. So I'm just going to put this is C now. And that half is still half, so I'm going to leave that half. So here's your formula. To find the area of a triangle, any triangle, you can go with half times base times A sine B. Notice where C is. Notice where A is. And notice where big B is. So you can literally rewrite this triangle, this area formula, 3 times. Does that make sense? So just for fun, because we want to practice things, you would write it as half times. Now I'm going to choose the first 2 letters. You tell me what sign I should be using. Half times A, well, not A, sorry. Half times A, B, sine who? If I use A and I use B, sine of who? A, if I use A and I use B, looking at the pattern here, do you guys all see my pattern here? I use C, I use A, and then I used angle B. I used C, I used A, I use angle B. If I use A, I use B. Very good. I use sine of C. The pattern there is all 3 letters are going to be used. Does everybody see that? All 3 letters are going to be used. Now, we call C, angle C, is the included angle of side A and B. Think about that word included. If I want to include all of you to, this is not real, okay? So just know this. To my next party, I'm going to invite all of you. All of you are going to be included. Does that make sense? Included. It's inside. I would find you all in wherever the party is. Does that make sense? Do you see that angle B is included between side C and side A? Does everybody see that? All right. I already know you and you know how to write the next formula, the third formula. Can you just practice? Can you write this last formula? Because there's 3 of them. There's one using CA sine B. There's another one AB sine C. And there's the third one. Can you write that out for me? Can you practice? This is just using patterns. When you're done, can you include it in the chat? If you don't know it, no problem. Just make sure that you know where to reference it. So first of all, which 2 letters or which sign am I going to do? Yeah, that's exactly right. Nice. So a bunch of you already got it. Okay, so I could just move on. BC sine A. Now, for those of you who didn't know, all I did was I took turns with which 2 sides I was going to use. And then I used the angle in between them. Some of you didn't see that. Some of you said, I use sine B, I use sine C, so she must be wanting sine A. You looked at sine A and you said, oh, it's that side, C, and that side, B, because those are the 2 adjacent to angle A. Does everybody okay with that? All right, moving on. So literally right now, done teaching. But this is just more practice for you. So it says Jamal and Jabari are helping Jamal's father with a construction project. He needs to help build a triangular frame as a piece to be used in the whole project, but he has not been given all the information he needs to cut and assemble the sides of the frame. He is even having a hard time envisioning the shape of a triangle from the information that he's been given. Here's the information. Side A is 10 meters. Side B is 15 meters. And angle A is 40 degrees. Jamal's father had asked Jamal and Jabari to help him find the measure of the other 2 angles and the missing side. Carry out each of the strategies below and then draw a diagram showing the shape and dimensions of that triangle to Jamal's father Jamal's father should construct. Provide measurements at an appropriate level of accuracy for the given project. So Jamal's approach is to first find the measure of angle B using the law of cosines, then find C using the law of sines. Versus Jabari's approach is using the law of cosines. Because we've never used the law of cosines, it's not on the test. Okay, but I wanted to show you just in case some of you wanted to use it. Now, if you know how to use the law of cosines, it could help you on the test, but it's not necessary. So I'm going to grab my law of cosines. And then I'm going to go back towards Jabari's approach. Where is he? He's right here. Okay, so I also need to write down this information up here. So I need to grab A is 10. I'm just going to take a picture of this. A is 10. Actually, I'll just draw it down here. So we got A is 10 meters, B is 15 meters, and angle A is 40 degrees. Okay. Oops, I wrote on top of it. Let's move this guy down a little bit. So Jabari's approach is to use the law of cosines. So I'm going to have you, well, as soon as this shows up, there it goes. I'm going to have you think with me, which of these should I use? Which of these formulas should I use? They're equally important. If you notice, it's the same kind of thing that we just did with the formula area, except for one uses the law of the cosine A, cosine B versus cosine C. Which of these do you think I'm going to use? Which of these do you think I'm going to use with this information? Yeah, I'm going to use this one. Why would I use the first one? Very good. Yes. Why would I use the first one? That's right. Why would I have to? It's actually a have to. Why would I have to use the first one? Very good. Because it's the only one that gives me A that uses sine the cosine. Because I don't know cosine B. I don't know cosine C because they didn't give it to me. Very good. Because of my 40 degrees. Exactly. Very, very good. Okay. So with that being said, it says solve for C using the law of cosines. So I'm going to plug everything into here. So it says A squared equals to B squared plus C squared minus 2BC cosine of A. So A is 10. So 10 squared equals to 15 squared plus C squared minus 2 times 15 times C cosine of 40 degrees. Okay, so what happens next is I just solve it. So then I'm going to, let's see, 100. I'm going to move this over. There's a C there too. Oh no, we're going to have to move it over this way. Okay, so this is going to be 100 equals to 225. 15 squared is 225. I think that's right. Plus C squared minus 30 C, and then cosine 40. I don't know what cosine 40 is. And then some of you are like, Ms. Johnson, I thought you said to plug in last. I can't plug in last because of what's happening here. So it's like 0.766. And then, so I guess that's going to be times this 30. So let's put 30 in front here. So I got 20. I'll do 22.98. So we got, let's see, 0 equals to 1. Let's see, what did I say? 22.98C. All right, so the next thing that I do is I notice that this is going to be a quadratic. Okay, and because it's going to be a quadratic, I'm going to use the quadratic formula. So I'm going to want 0 on one side. So I push everybody over and move it this way. And so I got c squared minus 22.98c plus 125 equals to 0. Okay, this is where I'm going to pause right here. For this part right here, I want you to finish this. And this is where we'll pick up tomorrow. Right before, or not tomorrow, but right before our test, just to show you what happens. It ends up being that there are two possible triangles. And the reason why there's two triangles is because this is a quadratic. Quadratics spit out two answers, right? And so you actually get two different answers for the length of C. Okay, so where I want you to finish this, and we're pretty much done, you don't need to know anything else, is I want you to solve this and then come up with two different answers. The other thing really quickly before we go is I want to go over this one takeaway. So in this section, you should have learned this formula. Could also be written like this. This is what we found. We came up with this together. This is if you know the height and its base, or the base and its height. This is if you don't. This is just any old triangle, right? The ambiguous case is what we just are finding right now, which is SSA. Notice if you flip this around, it's a bad word, right? So this was also the case in when you were proving triangles. This is a case that you can't use. You can't prove that side-side angle is congruent to another triangle with side-side angle, right? So it doesn't guarantee triangle congruence, and there's two possible triangles. So to avoid missing a possible solution for the triangles under these conditions, use the law of cosines to solve for that missing side. So Jabari's approach ends up being stronger because it pops out two different answers, versus over here, if you don't remember from solving triangles and law of sines, which I think that's what we're going to get into next, then it'll look like it'll only have one answer. So that's pretty much it. You are now able to do all of your work and make sure that you all are good.